Hello and welcome back. Today I have something really cool and I still can't believe I actually won the auction for the amount I did. And it is a big suitcase and even the suitcase looks very high quality already. And it's from a company called Pronova. It's in Germany and they are specialized in very high frequency and this is a very high frequency microwave frequency counter. So let's have a closer look. Already when you have a look at the suitcase, you can clearly see, okay, this is not one of those cheap suitcases that you can buy in the do-it-yourself stores. This is something proper. And it still looks good. And even when you look at the locks, how this works, there is a little grab and then it tilts back. And the suitcase is already very good. So I already have high hopes. So let's open this because it is about what is inside. And that the suitcase said Pronova doesn't mean anything. Well, it does mean that it is probably a quality product, but we don't know anything about the brand. Ooh, it looks kind of cool. It says XL microwave and don't confuse it. If you start looking now on eBay, you will probably come with this Philips air fryer XL. It's not that, I can tell you. And it says it's model number 3260. Here we have a better look. It is from Oakland, California, from USA, XL microwave. And it says here 26.5 gigahertz microwave frequency counter. Well, when it can do these high frequency, it probably has a huge display. Let me see, the power is set already to 220. Yeah, of course, it's from Germany, so that is correct. And then you can do plus minus 10%, so that should be good. It can also do external power, just DC, and then you just put anything between 11 and 28 volts. So you can run it perfectly on 12 volts. External reference in and external reference out. GPIB and whoa, big display. And it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 digits. So what else is in the suitcase? It really is a quality box. And there is some more things in because I hear a noise. Well, proper cable, really complete, and the keys, so we can actually lock it. That is nice. Well, that is everything. It seems that there is something here. Oh wow. It is the XL microwave, so it actually is a brand. And it even has a anniversary sticker. And it has the Pronova Messtechnik German manual. So XL microwave. I can't remember seeing this brand recently. They had 16 years of excellence, starting from 1983 to 1999. And they make some quality stuff. Yeah, this is the frequency counter. And all high sensitivity, super high microwave. Their basic model, it's the 3030, already goes to 3 gigahertz, and then it goes up way up all the way to 60 gigahertz. Up to 60 gigahertz. That's probably why they say microwave instead of just frequency counter. They say microwave frequency counter. And I've been looking on the internet, and this company XL Microwave was it's now together with Pendulum. And Pendulum is very famous for the frequency counters as well. So I joined with them in, I believe, in 2005. I read a Swedish article because some of the frequency counters by Pendulum are made in Sweden, just like Philips does the same. And you can see some similarities there between the counters also, so maybe it's even the same factory. Let's have a look at the counter itself. So look at this. Also, this looks still very, very good. And his last calibration was in the second quarter of 2007. That is a few years ago. And also here it says the Pronova. So this is really the one from Germany. Well, we have different times. We can do deltas of the frequency. There is no off button, so probably the oscillator is always on, and when you take it off standby, the rest goes on. Resolution changes, kilohertz, hertz, megahertz, gigahertz. We have even a dBm meter, so it can also do power measurements. That's pretty cool. And well, it's not the basic version, it's not the 3030, it is actually the 3260, which means it can go up to 26.5 gigahertz. I'm not even sure if I have a generator that goes that high, but let's see how much we can go. Now let's see here on the input it says plus 10 dBm oper, so it's probably a long time operation, and max short time it's plus 25 dBm, so the input can really take some beating in that sense. Well, 26.5 gigahertz, that is quite something. And then what about sensitivity? Because I've been playing with all the frequency counters before, and well, different from this quality, that's for sure. But they say, oh, it's a meter up to 100 megahertz, and then when you try it goes up to 120, 130 maybe. But then on very different sensitivities. I'm usually measuring with 50 millivolts, and some counters even go below that. But then the frequency, of course, the sensitivity goes then down after something. So I'm wondering, it is specified for 26.5, so at what sensitivity would that be? Oh, I by the way see that the basic model, the 3030, has a sensitivity of minus 45 dBm up to 3 gigahertz. And when I look at this model, that goes to 26.5, is minus 25 dB. I need to see how many millivolts that is, but I would think around 25 or something. So it can be put full of options, or you have like the battery option, you have like the 19-inch racks, airs. But if we look at the TCXOs, they have 6 options, and the last one being rubidium. It's pretty cool as well. I don't see an option sticker in the back, so I think mine probably just has the standard TCXO. And I also think having the standard TCXO, even though it goes up to 26.5 gigahertz, it means the resolution is just 1 hertz. But yeah, always looking at the hertz more or less if you are on 26 gigahertz. Oh, and if you would have the 6th option, the rubidium, the resolution would be 0.01 hertz. That's also kind of cool. So let's have a look around. Well, it's still, the quality is really good. The people were very sweet to it, it seems, but with the suitcase it is possible. Not even the sticker is broken. There is a sort of a warranty seal, calibration. A lot of screws. It is actually proper metal. It looks very good, I must say. So let's fire it up and see what happens. There is no on-off switch, so it will probably just immediately switch on. So yes, it is. Now it is in standby mode, and looking at my power meter. My power meter here says that we have now around 92 watts, and usually it is around 70, and that is my Philips, my other frequency counter. Now I can pull the plug and see. It's 74 right now, 75. So that means it's between 15 and 20 watts that it takes. So by default, it automatically switches on. It is in band 1, that is the BNC, and for the higher frequency they have this nice FMA. So it's in kilohertz. I think the power measurement probably only works on the higher frequency because you need, of course, the 50 ohms, and this one is 1 mega ohm. Well, without adjusting anything, just by default, I will just see if I put 10 megahertz from my distribution amplifier, and it thinks it's 10. So let's go to a higher resolution, even higher resolution. Can I add an extra one? No. Yeah, there it is. And you see that the gate time automatically extends. Do I get an extra digit? No, these are all the digits. So it's a 1, 2, 3, 1, 2, 3. So it's exactly 1 hertz. So it means it's 3, 4 hertz off. So well, it's running now for almost half an hour, and I don't see much change from the first 30 seconds, because in the first 30 seconds it was 4 hertz off, and now it's 3 hertz off, but that was already in the first 30 seconds. So it's super stable in that sense, and also heating it much longer, I don't see the difference. Probably when we run it from external reference, it should of course be spot on. So let's have a look at that. And yeah, we have an extra LED here that says external ref, and puff, immediately spot on. So here we have indication that there is external reference. If I take it out, then it will probably switch off again. Yeah, now it's off. Now it's running on its internal. And now I go back. Puff, spot on. And well, I read a little bit about this display time. This is the fastest, or it's even pause. I think it depends on the resolution you're in. This is then the 0.3 seconds, which is, I think, a second now because we are in the highest resolution. But when we go down, you can see it will go faster. And here we have the longest that actually does something. And if I push again, all two are on. This is infinity. But I don't know what you need with that, because then when does the update come? So I don't know what is the use of that one. And if we want to read the power, we need to go to this one. So let me see if I have some oscillator available. I have a few generators, but I think because it's a microwave counter, only the high frequencies are interesting in that sense. So I have here the SDG 1032, goes around 30 megahertz, updated to 60. I have here the 2082, I think it goes up to 120. But I also have the SG1 and the SG2, and let's have a look at those. I think they go to several gigahertz. So let me try this one first. I think this is the WB SG2 from a BG7 TBL, and pretty nice oscillators. This is the more luxurious, but it doesn't go that high, I think, but I can set the output power, which is also interesting. I will run this also from external reference. Don't want to scratch it. Switch it on. This one goes to 4.4. I'm in channel 2. Switch the channel. SMA. Good fit. No problem with the threads. Oh, off. Spot on, it is indeed. Wow. So look at that, 1080 megahertz, spot on. I don't think, maybe with the lights on, yeah, I hope the numbers are now more stable and the display is better readable here. Yes, it says it's 0 dB. So what if I do power measurements? Ah, look, here we have the frequency. And I think it thinks it is 2.3 dBms. So it's a little bit louder than it should be. Or it has to do with calibration. Interesting. So what if I add 10 dBs? Do I have then also 10 dBs? How much is this? I can't read, but let's just see. If I add that, will it still read? Or is it, do I have a 30 or 40 dBs? It says now minus 27. So, and the other was plus 2, so it's probably 30 dBs I have now in between. And that is also exactly even. Yes, it is 30 dB. So that works. That is pretty cool. Let's see if we go higher in frequency with this one. Let's go to full numbers. Does the power slowly goes down? Yes, now it already goes down. That could be my cable, or that could just be that the generator is not flat. These are very nice, but I don't know exactly about the quality. But it's cool. A few dB going down in the higher frequency. That is acceptable. Oh, yeah, now it's already in the higher frequencies. And what if we go again to the frequency? Look at that. This is 4 gigahertz. Can I change the power somehow? Yes, I can add some more. Okay, cool. That you can actually set the output power. And it should have a sensitivity of minus 25, I think. Can I do that? It's still measuring. I still see gate, I still see frequency. Okay, still measuring. Minus 30. Oh, and now it's gone. This is almost. It is very sensitive. Minus 33. Still working, but it is missing now sometimes a digit. And it was also specified for minus 25, I think, so. .6, now the PLL unlocks, so it's this generator goes up to 4.5 gigahertz. Let's see if I have another one that goes a bit higher. So that was the newer generator from BG7TBL, the WBSG2, and it's very nice. They are also models that go way higher than this 4.4 GHz, but I like from this model that you could set the output levels. Here I have an older model, it's a lot smaller. It's the WBSG one, and this one goes up to 8 GHz, but the thing is the output is fixed, so I need to play a little bit because it is a lot smaller. I don't know about the power, so it's around 0 dB on this 190 megahertz. Let's go a lot higher. Thousand. It's still around the 0 dB. Okay, and we lose maybe half a dB in the cable, or it's just too reasonable flat, to be honest. 3. Now it starts to drop. Oh, it's higher even. 4. And now it's lower. 5. 6, 7, 8 gigahertz, yeah. Yeah, on these high frequencies it's easy to lose a few dBs here or there, and I think it's the quality of the generator that it is just not that that it's not that strong on these high frequencies, and of course I lose a little bit in my cable. And now we are on 8 gigahertz. It says it's minus 12 dB. Should be able to measure a frequency up to minus 30 whistle, 25 according to the book. And yeah, with external reference, of course, it is spot on. When I take the reference out, we are of course off a lot now even. It needs to be calibrated. And with external reference off. Okay, let's go back to the other port. It should say 10, and it does. And how much are we off? Because now it's switched on for an hour. It's still this 3, so it's super stable. Let's see if we can adjust this, because of course I like it split on. I was just thinking, usually I try to find the limit of a frequency counter by putting a little bit more frequency higher, and then we see usually it's 10% more that the meter still gives a readout. Of course, with a little bit more voltage than the specifications say. So I use usually 50 millivolts in the specifications, just like now they say, well, 25, 30, depending of course on the quality of the meter. Some meters even want 100 millivolts, but these proper ones are usually below at around 25. And but now I'm running not to the limit of the counter, but to the limit of my generators. So maybe I need to find also a generator that goes a little bit higher than the 8 gigahertz. I'm not using it too much, but just to find the limit, because maybe this counter, it says 26.5, maybe it can go to 30, but with a little bit less sensitivity, but I cannot find out now. I want to open it. Oh, I need to break the seal, and it was a warranty seal, but of course the warranty is not there because it's from eBay, but still it feels a bit weird to break the seal. But there is, I didn't find any adjustment screw in the back to adjust the oscillator, and it is warm enough. Now it should be warm, so I will just cut with a knife. Yeah. That's it. I want to leave the seal on this time. And I think this screwdriver will fit perfectly Yes, it does. Interesting to see what it looks like on the inside. And also if we are able to adjust it. Oh, it's a little bit bent. Oh, another seal on this side. And there they put it on a screw. That is not nice. Yeah, that's a pity. Ooh. Now you can see it's a little bit older. It's all on sockets. That is nice. And the EEPROM says also it is a 3260. So does the EEPROM decide that, or there is a pot here, but that could be also for the power. So where I adjust the oscillator. This is a nice, this is hot, so maybe it's here. But that means, no, this is probably the pre-scaler. Here we have a look from the top. I thought maybe it's the oscillator, but I think we will probably find that this is the pre-scaler because it's all covered. The GPIB part, EEPROM. Let's have a look on the other side. Okay, well, I'm now opening the bottom, but I somehow hope not that the adjustment screw is in the bottom, because I have seen before that I need to be able to access the screw and keep the meter in the position as it is used, because if you put the frequency counter on its side, it will read differently depending on its quality, but usually it is, and it has to do with gravity and the oscillator, if it is a crystal oscillator. Oh, okay. Here we have. Okay. We find the oscillator right there. Yeah, here you can see it is really proper quality. All these cables here are proper. It's not, look at this. Everything is covered. Nice protection. Even the external reference here. It is already a modern power supply, but probably very low noise. And it looks kind of a combination between a switch power supply and a transformer. But there are a lot of coils to equalize all the DC, I think. Okay, well, if we look at the oscillator, it says here calibration, and it's due in October 92. So it has been a while. And while on the top it said that it was calibrated in 2007. So then you can see, okay, calibration doesn't always mean they are adjusting something. It just means that they look if it is still within specs. Maybe this 3 or 4 Hz was seen as, yeah, it's within specifications. I do feel a little hole here. So probably we can adjust. So if I carefully open it, yeah, let's have a look there. I hope we can see, but I will try to zoom in. I think there is a little screw in there. I put some light there. Yeah, you see there is a little screw, so let's try that, but let me show you. So of course I like it spot on. So I don't like that it is 3 or 4 hertz off. And well, it's still warm because it hasn't been switched off that long. So when I measure now my 10 megahertz, it is again this 4 hertz off. But usually when you put the frequency counter on its side, now even more. When you put it on its side, because you need to find the screw, it usually will change because of gravity. Wow! This meter is amazing. When it is on its side, it doesn't matter. Usually it will change a bit. Yes, it's now. So I actually can adjust it upside down. That is nice. That is nice. Well, let's see if I find something. I need some ceramic screwdriver. Yeah, I bought a few in China, different sizes. And sometimes they break, so I have a few. This one is now a newer one again. And you just put it in and just need to feel that it is stuck. Maybe I need a smaller one because it is not locking. Ah, now it's locked. Okay, now we just need to adjust it. Here we go already. Oops. A little bit more. It is pretty easy to adjust. Wow. It really. Let's put it again straight. Then I like to see what it does with 8 gigahertz. Mode. Switch over. Probably better try to adjust it like this, because then, because of the multiply factor, it would be more precise like this. So it's 825. Will it change if I put it like this? A little bit. 825. Okay. Yeah, it will change. That was expected. Okay, adjusting seems a bit more complicated than I thought, because the oven is just warming and cooling and warming like a thermostat. So on the, now it's rising, but later it will be dropping again. If I look at the 10 megahertz, it's all good because it happens all here on the back, so we don't see. So on the hertzes, it's no problem. But here, of course, the frequency is a lot higher. So a small difference will be a lot more visible. Now it's going up, but I will put the time lapse. We're just going to wait, and then you will see it will drop later. And I think that is kind of the thermostat of the oscillator. So this is as good as I can get it, and this is, in this scale it is actually a few hertz, but here we are below the hertz and we don't see it here. But also I need to be careful not to adjust above what the oscillator actually can do. So this is as good as I can get it, and it just goes a little bit up and a little bit down every time with the temperature changes, and it is now just getting hotter and hotter because it's 28.8, which is of course way too much. Should stay at between 21, 23 I think in the lab, and then this will also be more stable. Of course the oscillator is also a little bit affected by that, and in the end it is made for this scale, and then plus or one digit, and it is perfectly within that on this internal oscillator, because then it would be 0.337, and it is just getting there, and then it goes up again and a little bit down. I cannot expect much more from this oscillator. So the XL microwave, the 3260 up to 26.5 GHz. I was not able to test that. I could only go up to 8 GHz, but it is because of my generators just don't go higher. So maybe I need to look for something that does. I think it was a great find, and it was not expensive at all. And I'm so lucky with suitcase, papers, everything is there. And yeah, I'm happy with the result. I will be running it on external references anyway, so for me that is not a problem, but it is a little bit off, but it is a lot better than it was when it came, because it was 5 hertz off and now it's like half one. But the temperature is way too hot, so it's not good to adjust right now. But here we have it on its own oscillator. And pretty cool, it also has a power meter that you can just read out in dBs how many dBm, and then back to frequency. It's a pretty advanced meter, especially for that time, and well, it makes perfect sense for me that Pendulum thought, okay, let's take this company or have an alliance with them, because these people know their microwave stuff. It really looks good. So that's it for now. Thank you for watching, and hope to see you next time.